Thank you for coming to this. I'm going to say a couple of awkward things about names up front. So my name is Toby. That's not awkward. I work for a company called CodeCentric. I'm a consultant. We're hiring. So I go by the name of Weltraumpirat on Twitter, and it has a 3 in it. And if you're ever going to have a Twitter profile, don't pick something like that. It's a really bad decision. Nobody remembers it. Anyway, so design is how it works. Has anybody heard that quote before? 1 or 2, okay. So I was actually afraid to pick a title like that because it's a quote from Steve Jobs, and who does that anymore? Had you told me that I was going to do that about a year ago, I would have probably thought that, nah, never going to happen. But there's a twist to it, so bear with me for a while. Design. Steve Jobs was a product designer, right? So that whole quote about the product being more than what it looks and feels like is from product design. And when we're here at the conference like this, when we talk about DDD, obviously we're not talking about that predominantly. We're talking about system design. We're talking about the layout of components, about bigger scale applications and enterprises and stuff like that. So there's a connection. Design is how it works. What is the it in this? Any ideas? The product, okay. To me, it's the business, right? We have to understand how the business works in order to make good business products. That's what it's all about. And domain-driven design to the rescue. Obviously, we have a lot of really great tools for that. Event storming not being the least of that. That is the picture you find when you Google the domain model. I have no idea why it's UML, because that really doesn't have anything to do with it. But I couldn't find a better picture, so that's why it's on this. And we have hexagonal architecture as a really great pattern to let us design application in a good way. So all of this is great. We're using it all the time. We're starting a project. And really what for this project should be true for product design, it should also be true for the system design. So we have to understand the whole thing. We have to get feedback. The quicker and the more feedback we can get, the better the product is going to be, right? And reducing the time from our idea to getting the feedback is what's most important about that. And then the rubber hits the road, and we start our project. And we have all these great ideas. We did the event storming. We got our requirements right. We talked to the business people. We have an understanding. And things happen, right? Everything gets going. People are influencing the thing. We have contact with managers. We have contact with enterprise architects. Lots of things happen. And after a while, it's really hard to even see the design in that anymore. So, what is good design? People come to us and say, well, there's 20 different products that do half of what we want to do. Can we use them all? Can't we buy them all? You'd only have to implement the interfaces, right? How about we have to evaluate Kafka, or we have to evaluate the newest whatever technology? That's the hardest thing. Everybody's doing it. We have legacy. Everybody has legacy. Oh, there's an LDAP that we really have to hook up, right? That's the first thing that we usually do. Alternatively, landing page. What about performance? Let's optimize first. What about data privacy? Big thing nowadays. All of these things come in right up front, right? So then the company comes and says, we only use these technologies, A, B, C, D. Pick one. Whatever they assume for their usage is usually completely unrealistic. 1 million users per hour, right? How many times have you been in a project that actually had that requirement? How many times have you had to actually guarantee 5 nines of availability? It's in every contract. But nobody ever does that, right? I mean, most companies that I work for, at least, have 9 to 5 hours, and they're only in Germany, like especially the banks and the insurance companies that require all this stuff. So then there's developers, people. They have their favorite tools. Kafka is so great, we have to put it in. And of course, everything is distributed nowadays. Who remembers the first law of distributed systems? Don't distribute, ever. So, what happens is we start the project, 20 people work on it, and it takes weeks before we get the first thing even remotely delivered. Hello world on Kubernetes. We get the first actual customer feedback after I don't know how many months. And by the time that we get it, we already have entropy. The thing that we all strive for, the refactoring towards deeper insight, we can't really do it because we've already picked 20 technologies that are going to hinder us doing it. So we take the most important decisions at a time when you have no idea what we're actually doing. So if you've been in that architecture talk this morning by Dylan, I'm going to tell you the exact opposite. Reversing those decisions is expensive, so nobody ever does it. We do proof of concept. 8 weeks, we deliver a serverless thing. And then after 8 weeks, we say, oh, nice thing, we found out a couple of things. Let's just rework it. Let's do it over. Let's build a different thing because we learned it's wrong. Nobody ever reverses that decision. Sunk cost fallacy, if you've heard that before. We've already invested so much. Let's just keep going this way. So, lots of smart people working on pretty complex problems, obviously, starting out with great intentions, and it never happens, the good design. And it's been bothering me for I don't know how long, probably ever since I started working as a consultant, because I see it everywhere. And I started thinking about what's the cause of this, and how can we actually fix that? So for me, root cause of all of this is best practices. And that's, of course, not the only thing, but it's the thinking that's behind it. Let's just build a React application. It has this folder, and this folder, and this folder, and every React application has to look exactly the same. The classes have to be named after the concept that they're fulfilling, so they're a reducer, or, I don't know, whatever other thing is really important for the framework. It's a view, it's a controller, but everything just looks like the framework. Then there's something like state of the art. You should do it this way. If you ever witnessed that discussion about unit tests and Ruby on Rails, the whole thing about TDD is dead, that came about out of this kind of thinking. You should be doing it this way. Active record, no other way, right? So, patterns. We're all great having experiences with bad projects. We learned that having had this pattern would have probably saved our butt. So that's definitely going to be in the next project. It's what we call the second system syndrome. Everything has to be in there that we've learned before. Whether it actually matters, that's a totally different question. And then there's the whole enterprise architect thing. That's how we do it in this company. There's A, B, C component, let's do it that way. Planning fallacy comes in, so of course my project's going to matter more than I actually no, it's going to matter less than I actually think it does. It's going to be finished sooner than I think it will, because I already know all these steps, I already have all these best practices, because I already have all the parts. Here's the problem. So, have anybody heard of the KanDDDinsky framework? Okay. Best practices don't match with what we're doing. They only apply to simple problems, and usually when we fix simple problems, we have a framework for that. We don't ever work with simple problems. At best, we have complicated problems. That's when you got A, B, C. If all of them are true, maybe D is a solution, but there's also E. It could be either one. We have to figure one out. Usually, these kinds of problems are all technological. It's like the performance thing that I talked about earlier, or security, or scaling. All these things, technical, they're complicated problems. So we have complicated good practices to solve them. That's patterns for you. Now, the problem is that anything that's in the business domain, so the thing that we're actually trying to solve, doesn't really fit that. They're complex problems. They're people problems. And none of those actually ever get fixed by applying the thing that worked for this other problem. We have to have a different strategy. And that is actually building experiments. We have to explore the problem. We have to find out if that problem actually matches our assumptions in order to come up with good solutions. That's actually hard to sell, right? So your enterprise customer comes to you and says, we want to build this application. It should look exactly like this. They already have their network diagram laid out, right? And then you come, when you're doing my job, basically reverse engineer the solution that they're presenting you to find out what their problem is. And then when you come and say, your solution sucks, they don't like to hear that. Everything we have in the Agile toolset doesn't help. It's great for delivery. It's not great for discovery. We have to have a backlog. The whole burn-down chart thing will not work. How big is the backlog? If I don't know what the problem is, if I don't know what the product's going to be, I have no idea. Turns out some people actually came up with some pretty good solutions for this. The UX people, the product people, the people who design products. They have this great iterative approach of, well, basically the OODA loop, right? Think about the problem, make a list of what you want to build it, and then find out if it's right. Use personas. Find out who your users are. Know who your users are. Know their problems. Start with simple things. And then, as you progress towards a good solution, add complexity. In product design, it usually works like this. You start with a paper prototype. You draw stuff on a napkin. You go to someone, show it to them, get feedback. Really simple, really cheap, really quick to build. You can do 5 of those in a day, no problem. You do wireframes. So that's a bit more sophisticated. It's already in some computer system. You can click on them, they do stuff. Usually they're all fake. Then you do the simple design. That's still click-dummies. And eventually you progress toward elaborate design, and that's still click-dummies usually. And then they give that to the developers, and that's actually a problem. Because, oh, sorry, I forgot to mention this, there could be several iterations, so it's not a linear thing, right? You could have 20 prototypes of each type and jump back and forth between those phases. So this all happens without developers, usually. How many times have you been in a project where you got your UX design laid out, complete? You get waterfall. Pretty nice looking waterfall, but still waterfall. There's also a problem in that UX designers usually talk to users, right? And then they improve their daily experience. So if there's a bad product that they're using every day that already kind of solves the problem, they'll come up with a better one, and that's pretty cool. But when you're talking about something that's new, or when you're talking about something where you could improve the whole business flow, the whole process, that's usually lost. So I've been in a project where basically the first iteration of the UX design that we got was a glorified Excel sheet, because that's what people were using. It looked like a spreadsheet, just nicer. And for all those reasons, it's really hard to integrate those things with Agile, because when we find out that some things don't really work, or we want to change some things, or we want to de-scope some things, having that discussion after you've already done all that UX research and you spent all that money on coming up with good user solutions, that's really hard. Now, I have to say that last week I saw a presentation by Suze Hayworth at Lean Agile Scotland, where she talked about something that she calls Dualtrack Agile, and that's actually quite promising. And I saw Carola, who's sitting in the back, giving a presentation where there was a quite similar idea to that. So basically have iterations of doing an increment in product design, then do the technical implementation, and keep oscillating between the two. And basically, the UX people and the development people work together. I think that's quite promising, but it's not a part of this talk, because I only just learned about that. So, if I want to do this for domain-driven design, for system design, how should that look like? Understand the context of the business, build a domain model, evaluate against stakeholder feedback. Does that seem familiar? Because it's actually been around for 15 years. Turns out that Eric Evans, in the Blue Book, already meant this thing to be iterative. And he meant this to be a whole team approach. Crunching knowledge together. Everybody should be working on it. Developers with the business. And as new learnings emerge, you do the refactoring towards deeper insight, right? So it gets better. You throw a couple of things out there. You find the best one. Sadly, this takes time. So how long is it going to take until you find a good solution? I cannot answer that. I'm not going to give you any money to do this, right? Because I want to know when it's finished. That's a problem. We don't get enough time to do this. So pretty much all the DDD projects that I've been on do DDD first, which is good. But once we've agreed on some plan, then that's going to be the plan. So what if we could do both together? The UX and the DDD stuff. How would that look? So to me, this is 4 phases, really. It's the inception phase, where we talk about ideas. Conception, where we talk about making those ideas better, once we agreed that they're kind of the good direction. Concretization, when we find good features to match those ideas. And realization, implement them. So, start up building the domain model first, because of course it's good to understand the business before we start anything else. How many iterations? I don't know. How do we verify that they're good? Do BDD tests. That's all that it takes to prove that you actually solved the problem. Do outside in. Come up with good APIs. Use real data. Actual business cases from your customer's problem with actual data, not just some dummy that you're making up. And then build a paper prototype and make that match the business. Get your personas. You already got the actors from the event storming that you did, hopefully, in the beginning. You know who's going to be involved in what role. Work with that. Design user journeys. Do story mapping. All that works well. So, this is our artifacts after the first phase, or within the first phase. Probably we'll have about, 20 different ones of those. Pretty simple. And then when we've agreed on having a good idea, we build a wireframe. That's going to be some GUI technology, probably HTML, something, JavaScript framework. Very simple, just the GUI elements. and connect it directly to that domain model that you built before. There doesn't need to be anything in between. There's no security, there's no performance stuff, there's no network. It can run on the same machine. You can run your HTML GUI in a browser, and that can connect directly to the core. It's really important to have that quick feedback, right? So if you change something in the business, in the GUI, you can do it on that same machine. You can change the code in your IDE, recompile, show it to your customer. That's really quick feedback. And then you can also start tooling around your CD pipeline, right? So if you got a domain core, that's going to be a package. You can build that just as you would in a real project. You can set up your pipeline, you can set up your deployment, you can set up automated tests, all good. Now it looks like this. So it's a laptop, and it runs the web UI and the domain core. And of course, the BDD tests are still there. They're just running in the deployment pipeline. And then we go to the simple design eventually. And of course, reattach that to the domain core and get more specific, add more complexity, build more stuff, right? We can do all the good stuff from software crafting. We can have the test harness more elaborate, do unit testing a lot. Think about our dependencies. Who depends on what? When am I calling which part of the system? Should there be something in between, or should they belong to the same package? Pack them in the same folder if they belong together. Move them to different folders. See how they interact. Really important. And then encapsulate change. That's probably the most important advice that the Gang of Four gave us in the 1994 book. Everybody forgets that. The thing that changes should be in a box. So, we built a couple of those. And then there's more stuff, right? There's single responsibility, there's dependency inversion, hexagonal, there it is. Map from the core to the GUI, detach them. They shouldn't have the same data structures. And more. Right? So there's lots of iterations in this stage. And then we go and have more deliverables, right? So now there's an adapter in between. And we can have repositories. And of course, the simplest repository that you could build is a hash map. Right? So there's an abstraction, you have storage, but it's still running on the same computer. It's in memory. You can actually attach this stuff to your legacy. Right? If you have a network and that network connects to the same laptop that you have your presentation on, you can call the legacy system and you can pretend it's an actual thing. No problem. You can eventually have more elaborate repositories. Local storage, SQLite, file storage, all that can still run on the same machine. You still don't need a server, even. And then when you get to the elaborate design, so you actually know what product you're going to build, that's when you go full on with the complexity. That's when we extract everything into separate little apps, microservices, if you want. That's when you introduce all the kind of special databases, depending on what you need them for, right? Not everything is a NoSQL database. Not everything is a MySQL database. There's probably good use for all of those, right? But it depends on the use case, it depends on the kind of data storage that you need for a particular task. So having all the information that you've gathered until that late stage in your development process is probably going to end up making better decisions. Because now we know, right? We can introduce chaos engineering. We can run performance tests. You can run performance tests still on the same laptop, by the way. That's a for loop for you. No problem. Call your API through a for loop. Have something count the time that it takes to execute stuff. You can still make a good decision about which is the better algorithm, right? There's no need for all the fancy stuff. So, how do we progress? This is our image from the last iteration. And now we're going to do REST. So, still on the same machine, but two components. You got one running in the browser and one running in the backend, probably Node.js. And then you can have 3 apps, and they all connect to the same server. This is the first time that we're actually introducing a server-client architecture. All the time before was just one computer. And then you can separate your data storage and have actual databases. And then you can split the domain core apart and have microservices. And that's the whole development process for you. Now, this looks really simple, but a real-life iteration would probably look something like this. Right? So there's lots of back and forth. Or it would look something like this, where maybe you skip some steps in the UX, or maybe you skip some steps in the domain core, but you would still have a similar progression. All this is still part of the whole framework, if you want. It's not really a framework, but it's more like a decision-making table. So this is how this all plays out, right? You have your different focus, you have your different granularity as for the design, change strategy. In the early stages, you just rewrite, throw it away, do it again. There's no need to refactor anything. There's no need to keep stuff around. It's simple to build. Even in a complex domain, writing a domain model that has just classes and nothing else takes little more than a week. It's really quick. And then in the testing strategy, you do lots of user tests. Actually, we've used some stuff from the Google Sprint book for that. That's pretty good. I can recommend that. And then you go to a more automated, half-automated inner company testing in the later stages. This all fits really well with the lean startup. This all fits really well with the 3X from Kent Beck, if anybody heard of that. It's pretty early, right? Usually we start all the stuff that we know from agile development somewhere here. The other stuff happens without us. I call this domain prototyping. So I said already, it's not all the things that other people do. It's no one size fits all. It's not going to solve all of your problems. What it is it actually enables evolutionary software design. And I'm quite happy with it. It should apply at every single level of what you're doing in your development process. So having that table, making decisions, pretty good idea. And of course, I didn't come up with any of it myself. All I did was put it together and give it a name. So thank you, everybody whose shoulders I'm standing on there. Now, if you're thinking this will never work, it's a great idea, but never going to work in practice, I have news for you. We're already doing it. It's been 6 months, and it's been great. How did it work? I got the customer to agree on, we'll focus on learning. And basically, that only happened because they realized that they didn't know what they want. So it was a lucky coincidence. But they bought it. What we promised was that after 8 weeks, we'd have at least one functioning prototype, and it wouldn't just be a click dummy, it would be an actual application. It would do the actual work so that they could use that to run a user test. And they were thinking about actually selling the whole thing, which never happened, but that wasn't because it wouldn't have happened. It was just the salespeople made the different decisions. For the second milestone, we said, we're going to build a minimum sellable product, and you're going to be able to actually make money off of this now, after 6 months, not after 2 years. So that's the selling points. We got a team that consists out of 3 people from my local branch office of Codecentric in Frankfurt, 1 internal person from the customer, 2 nearshoring people from Bosnia, and a UX designer from an external company. We got the business support from the customer as a prerequisite. We said we need direct access to people that we're going to ask questions. That's really important. They gave us that. And we do remote mob programming. So everything on one machine with the whole team. We use pretty much all TypeScript for everything and nothing else so far. And in the beginning, we did something, we did the event storming, of course, and we picked a small part out of the big thing that we saw to start with the first iteration. We ran a Liftoff workshop. If you've read the book by Diana Larsen, I totally recommend that. So if you want to start a team that's working on something, having a plan for how that team grows together and becomes an actual team is a pretty good idea. And after 8 weeks, Milestone 1, we had 6 full iterations of that domain model. So full rewrite of the entire thing. Work 1 week, show it to the customer, it's not right, throw it away, do it again. If we'd done that with all the technical stuff involved, it would have probably taken a year and been really expensive. So that was quite cool. We found a lot of things that they didn't agree on. So the business people, one person was telling us one thing, another person was telling us another thing, third person was telling us another thing. Finding that, knowing that what you got was partially true, partially not, coming up with a solution that fit for all of it, that would have been really hard if we'd gotten a requirements document, right? We were able to drop one of those 4 bounded contexts that we picked in the beginning entirely because we found out it was not necessary. They had that in their heads, but the flow of the business worked just as well without it. Probably saved around 120 to 150K. Needless to say, they were really happy about that. And that came from the team. That did not come from the business. We discovered that. So it wasn't all great. That thing that I told you about the glorified Excel sheet, that's actually from this project. So first try with the UX design was a bit of a mess. They went straight to the simple design. They skipped the prototyping. And, well, that didn't go so well, but after week 2, we clicked, and we did a lot of stuff together. So they came up with an initial design. We made some suggestions as how that could be better, back and forth. It's really cool because with the model that we're using, we can actually go from the design to an implementation that works and can be tried out within a day or 2. So it's really, really quick. And we learn, both of us. Now, phase 2, after 4 months, conception, it's really cool that we're having a product to show, right? So every time that we're having any interaction with the customer, not just in reviews, any interaction, we have an actual thing that we can test, that we can spin up, and where they see the latest stages of development. It always works, it never goes down. We're still thinking only about the business, so no other technology. 4 months, not even a database. We had user tests pretty much every 3 or 4 weeks, where we got 5 people in who were doing the actual work. We could see them perform tasks with the system. We took a camera and made a video of it. We had reflections on that, so it was really, really great feedback. A lot of assumptions were killed in that. You assume that some things are obvious, and then a person sits in front of the screen for 5 minutes not knowing which button to click. That's a pretty strong feedback. Yeah, we're still not running a single database in 4 months. That was really a new thing for me. So 5 months. We did a spike. We were using Angular because the customer said that's what we use here. We tried out React. 1 week, found out it wasn't what they wanted. But we were able to do it with the same domain core, no problem, no problem fitting it in, no problem developing it in parallel. We introduced an event bus, so everything's decoupled now. We got real actual events in the system that we can track, no more just calling methods. We introduced roles and personas into the code. 5 months in, everything until then, experiments, lots of experiments. Now, this is pretty close to where we're at now. It's the last month, if you want. We introduced REST because we had different roles. Now we need different work interfaces. We need to separate them. We have different laptops connecting to a server. We introduced microservices. We deployed the whole thing to Kubernetes. We upgraded our deployment pipeline to take care of the whole thing. And we're probably going to be 2 or 3 weeks early for the delivery, all in the last month. Now, is there anything big in there? Probably, there's no Spring Boot. There's no additional complexity. We still don't have security. There's still a lot of work. But we promised and we delivered. And we did it in a way that allowed us to postpone every single decision until the time that we actually needed to. And to me, that's absolutely powerful. Not everything worked out great. I should say that too. There were challenges. There's a team, so there's people involved, right? So that doesn't happen by itself. None of them has ever worked that way, neither have I. First one, right? So we had to find out how this thing can actually happen. We were lucky in that we could get Woody Zuhl to do a mob programming workshop with us, so that helped quite a lot in the beginning. Whenever devs hit anything that they're not comfortable with, they gravitate to what they know. So you leave them alone for a week, they're going to go and do their old stuff. That happened twice. There was efforts to keep the domain and the data model and the GUI in sync. So basically, what's an example? So I have a shopping cart in my domain model. I also have a shopping cart with everything that a shopping cart could ever need in the GUI. Instead of going by the form that I fill, or the list that I see, or whatever other thing appears in the GUI. That has only a fraction of the data. So no mapping in between, which means anytime you change anything in the core, it has to change in the GUI. That's what hexagonal does for you, by the way, that decoupling, right? So none of the people in the team except me had ever really worked with TypeScript or JavaScript. So that was a new one. If you ever hear anyone say to you, oh, but we need to use technology X because we can't recruit for it. Good developers can actually learn that stuff pretty quickly. Crafting, well, let's just say it was more of a diverse background that the people brought to the team. So some people were pretty good. Some other people had to learn TDD and all that stuff. And of course, DDD, same thing. So all of these things we had to kind of find ways around. And then there's management, and management always wants predictions and estimates, and they always want to have a say. And next week, I'm going to have a sit-in with someone from the enterprise architecture team to explain to them what we're actually doing in this. That's going to be an interesting meeting. But at least I was able to talk them out of doing estimates, right? So a little partial win there. Right, so if I haven't said it enough, this was a great experience. I'm really proud of what we did there. The team is awesome. The whole atmosphere is really relaxed. We got to do our way and not get any stuff in the way that we weren't actually focusing on. So it was really, for me, a feeling of always having the luxury of thinking about the most important thing. I can't say enough how good that feels. Now there's code. I could show you a lot, but I'm not allowed to, and also that would probably take another talk. And I'm not sure about how much time there's left for questions. I probably ran over already. 10 minutes? Okay, that's cool. So yeah, I'm happy to answer any questions that you have. I have some suggestions, of course. So yeah, you can do this in any environment. It can be done in a brownfield project, and that's not even really hard. So I can explain that. How did I come up with this? Well, that's a long story, but I'm willing to tell it over a beer. And I'm sure that there's lots of other stuff to discover here. And I want, if you have any feedback, please give it to me. I'm going to figure out ways of making that work in the next project that I do that works this way. I also want you to try this. So I got last week a call from somebody who wants to do this in the Netherlands, and I'm really, really happy about that. So if you want to do this, I'm going to consult the hell out of you, right? It's going to be awesome. And if you're going to work with me on coming up with better ways of improving this whole concept, then I'm all for that, because I really don't want to be the only one doing this. So much. Are there any questions? Marco said that.
Yeah, in the beginning. I mean,
Well,
10 minutes left.
yeah. So basically, anything that works for DDD in other projects, all the patterns that we have, starting with anti-corruption layer, also work for this. Right? So the easiest thing is, if your legacy system has an interface, then just call it. If it doesn't have an interface, build one. I build a REST interface on top. You can integrate. Right. And this pretty much works for any new feature that you're going to build. So you can do this in very small portions and add it to the stuff that you already have. And you can go for technology X that you already know, right? It is not required to do this in JavaScript. It just works well because it runs in the browser. But you could do server first and have an HTML interface. So that would work, but just as well, probably. Does that answer the question? Cool. Hold on. Sorry? Yeah, so we did mobbing exclusively in the beginning. And, well, as it happens, people are getting bored with whatever they're doing for a long time. And it looked pretty cool for me. Like, I was there I'm only there 2 or 3 days a week, so I'm not always with the team. But I was sitting in the back of the room working on a presentation, and I was watching them when all the people from Bosnia were in the same place for a presentation. And the mob was standing around a table like this. There was a big screen, and they were switching 2-minute intervals, right? So basically, tick, 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 tick. Next one. It looked like Tour de France doing circles. Really awesome. They tried every single way of doing mob programming that is in the playbook. So pretty much, do it this way, do it that way, do it navigator first, all kinds of things. And then eventually they got bored, and we started thinking about how can we, we've been doing this for a while, we could probably just parallelize things. Day 1, 5 hours in, we got the first big merge conflict. So let's just say we found out really quickly that having a single piece flow is actually quite cool. No, it's not exclusive, and obviously when you're doing mob programming first, there's always ways of, when I feel like I don't want to be in the big group because I'm overwhelmed or I'm out of energy or something, I can just take the laptop and do some grunt work, something that nobody wants to do, like refactor some configuration files or stuff. The shitty tasks that nobody wants to do, that's a pretty good thing to do by yourself. I did not say that. Okay. Mm-hmm. So when you use JavaScript, the stuff that doesn't run in the browser runs on Node. It's the same code. So I can pretty much do the domain core not knowing where that things going to run later.
That's an add-on. It's a possibility, right? But it's not the. Now I have Java or PHP,
Yeah.
or I have that.
Nope.
And
So how did the reasoning come about? So JavaScript was for me an obvious choice because we had very heterogeneous backgrounds. Everybody had used other technologies. What do you pick? You pick the thing that has the least barrier of getting into, right? I mean, learning how to work with Node.js for anyone who's done object-oriented programming before takes maybe 3 days. It's not a big issue. So that's how we came up. If I wanted this to change, and I'm guessing that enterprise architects probably going to have some arguments about that next week. Now that we have the REST interfaces, we can just unplug them and put something else in its place. I wouldn't do it earlier, but when you got the network in between, you get all the maneuverability that you get from microservices. More questions? All right. There's one more. Well, well, the both of them are integrated. So basically, anytime I show them the GUI, they're actually running the real application. It does what it does. It just doesn't have all the technical stuff in between. So for trying out, they get the full prototype. For having conversations, we had a lot of discussions about the model on whiteboards and other things. For our understanding, basically, anytime we're asking them things, we use whatever means we need to get to an understanding. But for the user tests, we invited people who are doing the actual work that this application is supposed to solve. I'm not supposed to talk about any details, but it's about airline catering. So it's a really complex domain, very, very complex domain. And they have a handful of people who are real specialists who work with the stuff. We invited them. They came over. They sat down on the laptop, and they started doing what they do every day. We gave them a task to do. And then we found out that, oh, this button's in the wrong place, or they didn't quite understand what we meant when we say add meal or something, right? So we had more learnings from that. And we repeat this every couple of weeks, because every couple of weeks we have more features, right? Okay. Well, the thing that we're building is a product, and the product has both an interface and a model. It's built together, right? So what we're getting reviews on and tests on is the full of it. It's an application. Of course, we have design discussions with some of the customers, and we have discussions about how the business works. The technical stuff hasn't really been an issue for anyone except for that enterprise architect that's going to come up. But there hasn't been any discussion about whether this should be microservices or something. Who's sitting in front of the computer doing the test? They don't know. They have no idea how this runs, what it runs on, what it's built like. All they see is the application, and that's all that we want them to see. All right, I guess we're done. Thank you.